So today we'll be covering the chapter 7.1, area of a region between two curves. Alright, so for the first step, we're going to sketch the curves, and then step 2 is draw and label the representative rectangle. So if you can see here, the curves are already sketched, and then that is a representative rectangle. And then, excuse me, and then we identify change of x or change of y, which is, this is a change of x because it's top to bottom. And then step 3 is to find the intersection of curves A and B. So basically figure out where, this is A and this is B, figure out where A and B, what are your intersections? So where is your curve from what point to what point? And then you identify your change of A, which is your area, equals change of f of x minus g of x, and you simplify if you can. And then step 5 is you complete the integration, and you just basically solve the integral, just as we would do any other time. And remember that it's always a to b, top minus bottom, dx, or c to d, right minus left, dy. But this right here, a equals a to b f of x minus g of x dx, is just your general formula for these problems, for this area of a region between two curves problems. So let's do an example. Let's do the example, find the area of a region bounded by the graph of y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So here, so let me just write this down really quick. Hold on, give me a second. So since in this problem, they're going to give you the A and B, so you don't need to worry about the A and B, like finding the A and B in this problem. So these are your equations right here, and then now I'm going to draw a graph. My graph isn't going to be a sketch because I do not have the lines to draw it right now, but this is x squared plus 2. This is going to be this is x squared plus 2, y equals x squared plus 2, and then this right here is y equals negative x. And then we know that x equals 0, so x equals 0 is right here. And then we know x equals 1, so let's just do it right here, and we'll do x equals 1. So we know it's between right here, this area, right here. That is where our area is going to be of what we're trying to find. And at this point, since we know, because we know that, our general formula, do you remember? It's A equals A to B f of x minus g of x dx. Right? So we know that's our general formula. And if we know that, we can set this one right here because it's top to f of x, so it's going to be A equals A to B f of x, x squared plus 2, because x squared plus 2 is f of x, minus g of x, which is negative x, and that is our formula at the moment. That's basically what we have to do. Oh yeah, sorry, and I'm going to erase this now that we know our general formula. That is d of x. Right here. Alright, and now that we have that, we can actually put our A and B, we can plug in A equals 0, because we know 0, it's from 0 to 1, 0 to 1, so 0 to 1, and then we can plug x squared plus 2 plus x dx. Alright, now all we do is we take the integrals of all of them. So you're going to get x cubed over 3 plus 2x plus x squared over 2. 0 to 1. Because it's 0 to 1, you don't have to worry about the 0, so you can just plug in 1 to all of them. You're going to get 1/3 plus 2 plus 1/2. And then your answer to that, if you do all your math correctly, is 17 over, 6. So I don't know why I wrote 16. 17 over 6. So as you can see, what we did was we found the area between the top minus the bottom, and then it's the same exact way from right to left. If this was switched around, you can just do right to left, but it's the same exact equation, and it's f of x, g of x, just right minus left, and top minus bottom. That's exactly how you find the area of a region between two curves.